There we go. Not forgetting to record. All right, so we're going to start looking at quadratics. So we've dealt a lot with linear equations so far. Our story problems yesterday all had to do with linear equations. Like everything was lines. So now we're going to deal with less lines. We are going to get into quadratics. We should know this, like we've seen these before. And we have a few different ways we can go through some things. And we're going to see several different ways of solving today. They shouldn't be particularly new, but we're going to see several ways. So if I asked us to solve this first one, x squared equals 49, what would you do? Square root both sides. Absolutely valid. I can take the square root of x squared, and I can take the square root of 49. What is the square root of x squared? Just x. What is the square root of 49?
7.
I was going to say or -7. So we're going to use our plus or minus 7. Because my x could be 7 or it could be -7. -7 squared is still 49. So we're going to have two answers here. So the middle one, very similar vibe. We can do the exact same thing. I have my square all by itself, so I can do the square root of x squared, and I can do the square root of 45. This may be a little harder to spot. Square root of x squared is just our x. And then I'm going to do another square root section here. And I'm going to show you why in a second. So we want to put this in simplified radical form. We're not going to try and put this in a decimal, because ew. But we want to simplify the radical. So are there any perfect squares that are factors of 45? 9 and 5. So I can rewrite 45 as 9 times 5, right? Valid. Well, if we remember our radical laws, so I'm going to do that real quick. In radical laws, it means I can separate these out to be square root of 9 times the square root of 5. What is the square root of 9? 3 times the square root of 5. Or 3 square root of 5. However, remember we have our two options of solutions. So this was plus or minus 7. So this is plus or minus 3 square root of 5. Just put it in the front. Plus or minus 3 times the square root of 5. So that one's a little bit weird. Questions on that one? Okay, so that's all we mean for simplified radical form. Find a perfect square that's in it, simplify it out. Simplified radical. Let's look at the right-hand one. What can we do here? Square root both sides. I have a square that is isolated. Absolutely fine. I can square root my x minus 4 squared and square root 81. The square and the square root cancel out, so we're left with just our x minus 4 equals plus or minus 9. When we take the square root of a perfect square, so if I cancel out a squaring, we have to watch out for that plus or minus. It's this part that gives us the plus or minus. So over here it was when my square root and my square canceled out that gives us this plus or minus. It's when my square root and my square cancel out that give us this plus or minus. Okay, that's where the plus or minus piece comes into play. It's going to give us two solutions. So we're going to have to figure out when x minus 4 equals positive 9 and when x minus 4 equals negative 9. So we're going to wind up with two solutions. We wound up with two solutions on all the others. They were just very matchy-matchy. Did I just hear I'm lost? Okay. So on this one, what do I do to figure out my solution? Add 4. So my solution on this left-hand piece is going to be x equals 13. Add 4 to both sides. On the right-hand piece, what are we going to do?
Add 4.
Add 4. So what is our solution over here?
Negative 5.
Negative 5. So when we have something being squared that's all by itself, go ahead and do it square root style. Just watch out for our plus or minus. Okay? That's usually our easiest option. Usually. Not saying it's our only option, not saying it's going to work every time, but it's fairly fast and fairly simple. Okay? Questions on any of these three? Okay. Because just for warning, it is not going to stay that simple. I'll zoom it in so we can see a little bit clearer. So this says solving using the quadratic formula. And we get a little bit weepy because we go, oh no, quadratic formula. You can try and solve it another way. Like if you want to see if it can factor, you can try. It's not factorable though. That would be looking for something that multiplies to make negative 8, adds to make negative 3. Not working. Okay, so we're going to use our quadratic formula. If that is not something you know off the top of your head, we need to start working on that. There are many, many songs that can help you remember it, but you need to know it. X equals opposite of b plus or minus the square root of b squared minus 4ac divided by 2a. There are many, many songs that you can use to help you remember that. The classic one kind of goes to Pop Goes the Weasel. I sang it the other day. There are many, many, many covers. I'm sure your favorite song most likely has a cover of the quadratic formula. They're amusing. So we're going to take these pieces. We're going to substitute it in. So, I'm going to change this to black. What is my a value here? 2. It's what's in front of the x squared. What is my b value? Negative 3. What is the c? Negative 4. Those are coming from my standard form. So I'll put it up here next to the quadratic formula. Our ax squared plus bx plus c equals 0. That's where we're getting that a, b, and c from. It's coming from our standard form. When I do these, I always start out with pure substitution and not simplifying anything in. It makes it much easier to check that I got all the pieces in all the right places. And I will almost always color code like this. So we're going to have our x equals our opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. And I like to do this color coding style. It makes it very easy to spot check that I have 2 A's, 2 B's, and a C. So for this one, I have 2 greens, 2 pinks, and a purple. Make sure you substitute the pieces in first before you start going full tilt boogie with your simplification. Because if they're not substituted in the right spots, there's no chance of it being right. So then we're going to simplify this as much as we can. ideally down to simplified radical form. So what pieces can we simplify here? Yeah. So we know we're going to simplify what's in here. What happens when I take the opposite of negative 3? Positive 3. Plus or minus the square root. And you can do this in 2 steps or you can do it in 1 step. I'm going to do it in 2 steps. Negative 3 squared. 9. Minus 4 times 2 times negative 4. Negative 32. So we have 9 minus negative 32. Which means what are we doing with the 9 and the 32? Adding them. Our denominator is going to be a 4. So we're going to have 3 plus or minus the square root of what is it? 41 over 4. Can we simplify square root of 41 at all? Is it important to check? Yes. Yes. Because sometimes we will be able to simplify, and I'll show you what that looks like in a minute. Okay, so this is our total fully complete answer. You can leave it as plus or minus. Yes, dear?
What is the quadratic?
That's this guy up here. I'll put it right at the top, and then I proceeded to zoom in and not leave it up there for you. This guy up here, this is our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac divided by 2a. Again, if you need help with a song, there's one on to Superman with 2a. It's pretty epic. Love it. It's fantastic. Okay, so we're going to try this again. I'll zoom it in, but I'll leave the quadratic formula up there for those of us that still need to write it. So here's our right-hand one up here. I've got 6x squared minus x equals 2. What is my first step going to be? Set it equal to 0. We got to subtract 2. I heard it in a couple different ways. Both are correct. Subtract 2 from both sides because it has to equal 0, has to equal 0, has to equal 0, not optional, has to equal 0. If we have an x squared, you set it equal to 0. So we're going to have our, wrong pen, 6x squared minus x minus 2 equals 0. All right, so we were specifically told to use our quadratic formula here, so we're going to do so. What's our A? 6. What's our B? -1. And what's our C? -2. Okay, so we're usually pretty good at finding those pieces. This next step is just substitution. I always substitute it in without simplifying anything because it helps me make sure I get stuff in the right spot and with the right signs. The signs are usually where we get tripped up. The math we're usually good with, it's the signs, the little minutia, the teeny tiny pieces. That's where we lose stuff. So x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. All right, I'm going to cover up the quadratic formula for a minute. I can always put it back up. I just want to make sure we can see what we're doing here. So we're substituting these pieces in. Then let's simplify this as far as we can go. First thing first, opposite of -1 is +1. Plus or minus our square root. -1 squared, 1. minus 4 times 6 times negative 2. Negative 48. And we're over 2 times 6, which is 12. I'm going to give us that one. So, ooh, chonky pen. There we go. X equals 1 plus or minus, what's our radical? 49. Whew, we can stop here, right? Why? Because we know the square root of 49. Simplify it. So x equals 1 plus or minus what? 7 over 12. If we get here, finish it. Get me all the way to an answer. Meaning we're going to split it and get our two answers. Split it out. We're going to have 1 plus 7 over 12. And we're going to do 1 minus 7 over 12. So one of my answers is going to be 1 plus 7, which is 8 over 12, which simplifies down to be what? 2/3. Slow down on our simplification sometimes. And this one is going to be 1 minus 7, negative 6/12. So negative 1/2. So if we can get us all the way down to solutions, I've got my two roots here. Two solutions, roots, intercepts. Okay. Questions on these ones? We're going to do one more quadratic formula one. I know, we start to look at it and we go, ooh. Absolutely a valid option. Okay. So we're using our quadratic formula. I'm going to write it up here again. We should hopefully have it. I'm going to zoom the page out for a little bit. We will not give you this formula on like tests, skills checks, anything. So you have to know it, okay? We do not give you guys any formulas. I know. And that's coming from IU. Like, we do not give you any formulas, no reference pages, nothing. We got to have them all in our brains. Huh? Nope. Not even on final. So, option 1, plow through as we are. Fraction and all. Absolutely valid, totally doable, harder math. Option 2 is to go, ew, I hate fractions. What is our solution for I hate fractions? Multiply by the denominator. As long as I do the same things to both sides of my equation, I can do whatever the heck I want. I'm going to multiply both sides. Absolutely wrong, pen giant, holy cow. Both sides by that denominator. Everything. I need to multiply everything by that denominator. So 2 times 3/2 z squared gives me 3z squared. 2 times 4z gives me minus 8z. 2 times minus 1 gives me minus 2 equals 2 times 0, 0. We could try factoring again. We need to multiply to be -6 and add to be -8. That's not a thing we have. That's not things we know. So unfortunately, we do have to use our quadratic formula. So again, you can do this with it in fraction form. It still absolutely totally works. It's just a little bit harder math, but it's totally fine. Easier way is to do it this way, and then it's exactly what we did before, where we find our A of 3, our B of -8, and our C of -2. We will get the exact same roots. Since we're looking at our roots, solutions, x-intercepts, it still gives us the same spot. So going through our quadratic formula, substituting our pieces in, we get our opposite of b plus or minus the square root of our b squared minus 4 times a times c divided by 2a. Substituting all the pieces in. I always prefer to substitute them in without simplifying things. It makes sure we keep track of what we have simplified, what we haven't, and make sure we didn't miss any signs. Because when we come through and simplify here, what are we going to get? 8 plus or minus square root of, ooh, I hear many things. So 8 squared is 64. 4 times 3 times -2. -24. So we're going to simplify. I'm going to bring it up to the top so we're not working right so far at the bottom over here. So we have our x equal, or actually, sorry, we're on z's here. I should keep my variable the same. Our variable was all z's, so it should be z's. Z equals, I totally lost track of that. We are on z's. Z equals, not usually, no. I'm not usually that petty. It's just best practice to keep your variable the same. So I'm going to go back and fix those. Switch them back. I always put a little crossbar on my Z like that. That's not a math thing. That's a so you can tell it's not a 2. Because my handwriting, my 2's and my Z's sometimes look real similar. So that's the only reason for the crossbar and the Z. So when we simplify this, we wind up with our 8 plus or minus square root of what? 88. Over 6, excuse me. Can we simplify this? Yes, we sure can. How can we simplify this? Technically, it does divide by 2, but what? I need it to be a perfect square in order for it to be helpful. 4 and 22, right? I want to find a perfect square in there. I need it to be a perfect square. So yes, technically 8 times 11 would work, but 8's not a perfect square. I need a square since we're dealing in square roots here. So the reason we do that is to get this into simplified radical form. 8 plus or minus, what's my simplified radical form? 2 square root of 22 over 6. Is there more simplification we can do? Yes. Look at your coefficients. Treat this guy like a variable. Square root of 2. Or square root of 22, that's a variable. Look at our coefficients. 8, 2, and 6. If it helps, think about how we can remember how much we love to divide. These guys. We can simplify these. They're all divisible by 2. Which if we think back to what we did at the very beginning, since we multiplied everything by 2, that's where that 2's coming from. So what we have is really 4 plus or minus 1 square root of 22 over 3. Okay, so the additional simplification on our simplified radical form, that's a 1 here in case that helps us. Make sure we're looking for that when we're especially in our quadratic formula stuff, especially if we've multiplied to get rid of a fraction. Almost always that will make us have to simplify. Not going to say every time, but a lot of times. Okay? Questions on this one? Yes, dear.
Can you explain why you do the 88 to the 4 and 22?
So I just split 88 up into things that multiply. I can split 88 up in a lot of different ways. If I just think about 88, I could split this up to be, 1 times 88. I could do 2 times 44. I could do not 3s, but I can do 4 times our 22, not 5s, not 6s. I think our next one is going to be 8 times 11. And so it's just factors. It does matter which one we choose because the only one of these that has a perfect square is this one. 4 is a perfect square, which since I'm doing a square root, I can simplify that. That 4, the square root of 4, turned into the 2 on the outside. Okay, so we're looking for those factors, trying to find that perfect square to pull out. So we need a perfect square that can come out of there. And if there's not a perfect square in there, even if it has a gazillion products, if it doesn't have a perfect square, it doesn't simplify. And that's okay. Okay, good questions, guys. This is our last quadratic formula one for the day. Yay. We love no more quadratic formula. We still have 15 minutes. We ain't at that. Because our other option is to solve by factoring. So we're going to remember how to factor. I know we've done factoring recently, but we're going to solve with factoring. Solving with factoring. So our left one says 75x squared plus 35x minus 10 equals 0. What's our first step when we factor? Check if there's a GCF. Is there a GCF here? Yes. And I already heard someone shout out we got a 5 as a GCF here. So I'm going to take a 5 out as our GCF. It's going to leave us with 15x squared plus 7x minus 2 equals 0. So we always check for a GCF first. Then we're into our factoring part, so we can try and factor this guy. And there are lots of techniques for factoring. I'm going to use factoring by grouping up here. It takes up the visually less screen, but if you like boxing, if you like split the middle, bottoms up, there's lots of techniques to do. However you choose to factor is fine with me. I just need you to factor, okay? So for every technique, we need to figure out our pair of numbers. That's when we take our a times c at the top. My 15 times negative 2 is negative 30. And our b goes at the bottom, positive 7. We need a pair of numbers that multiplies to make negative 30 and adds to make a positive 7. 10 and negative 3. My a value is not 1, which means I cannot take the shortcut of x minus 3, x plus 10. Cannot take that shortcut. We have to do something else to factor. Either it's factoring by grouping or using the box or some other technique. I'm going to do factoring by grouping. So my GCF of 5 is just going to hang out front. And I'm going to do a big bracket here. So we've got our 15x squared minus 3x plus 10x minus 2. Okay, so I just made it really big. Because again, I'm going to do factoring by grouping. So I'm going to break these into smaller pieces. So I'm breaking these into pairs here. My 5's still going to hang out up front. I'm just going to ignore him for a hot minute. What is shared between 15x squared and minus 3x? Three and x. What's left over when I take 3x out of 15x squared minus 3x? 5x minus 1. What is shared here between 10x and minus 2? 2. So that plus is coming down, and then we have a 2 as the GCF of those two pieces. What is left over when I take 2 out of 10x minus 2? 5x minus 1. I had a lot of people on the last quiz think that this counted as factoring by grouping. This is a middle step. This is not your factoring. Our factored form, I'm going to change my view real quick just because I need more space. Our factored form here, this 5 is still, we're ignoring him out here. He's still hiding. We take our 5x minus 1, and I'm going to pull that out like a GCF. I put it in front. 5x minus 1. My factor, other factor, is the pieces left over, the GCFs that I pulled out. Pull 5x to the front like it's a GCF. My leftover pieces are 3x plus 2. This is my factored form. Once we get the hang of it, it goes really fast. But I know I'm slowing the brakes on it so that we have a chance to see it. That's my factored form. Now my big black brackets are not actually doing anything. It was just my way of keeping my GCF separate. So this is my fully factored form. Questions on the factoring part of it? Because we still have to solve it. We're not solved yet. Solution means I need an x equals. How do I get an x equals from factored form? Set each factor equal to 0. So we need to do our 5x minus 1 equals 0 to find out what that root is. And my 3x plus 2 equal to 0 to find out what that root is. So we're going to solve each of these individually. I'm good at talking. So on the purple one, what are we going to do? Add the 1 to both sides. So we have 5x equals 1. Divide by 5, we get our first solution as x equals 1/5. Right-hand one, green one. Subtract 2. So we're going to have 3x equals -2. Divide by 3, x equals -2 thirds. Okay. The 5, since it doesn't have an x, it doesn't actually have a root. All that is, if you think back to when we did quadratics in Algebra 2, that's a stretch. So it doesn't change where your roots are. It just says it's going to have these two roots, and it's going to go whoop, stretched out. So the GCF doesn't have anything to do with your roots. That's why we pull it out and just kind of leave it out of the way. I ignore him. Okay? I want to do one more, but I don't want the other one on this page, which is why I've zoomed it in. Because in the homework, we get one like this. So I want to make sure we do it. I want to make sure we do one like this together. Okay? So we see fractions and we go, what do we do to start our process of getting rid of fractions? multiply by our common denominator, right? So think about what we would do and what might be our least common denominator for all three fractions. Yeah. X squared minus 9, that's a difference of squares made up of the other two pieces we have. So I'm going to write it out in factored form because it'll help us when we come to our multiplying. So we're going to have our x minus 3 times x plus 3. And we'd really like it to not have fractions anymore. Thank you very much. So I'm going to multiply absolutely every piece by that least common denominator. And I'm going to write the whole thing out, which is going to make it look like a hot mess here for a second. So I'm going to have my 5x over x minus 3 times that common denominator of x minus 3, x plus 3. Plus, multiplying it times all my pieces, 4 over x plus 3 times x minus 3, x plus 3 equals the fraction of 90 over, and I'm going to put this in my factored form, that x plus 3, x minus 3, since this is a difference of squares, and we're multiplying it by x plus 3, x minus 3. Multiplying absolutely every piece of this problem by that least common denominator. Does everyone see what I did, even if we're not entirely sure why I did? I'm going to fix that because that was just trash handwriting. Does everyone see what I did, even if we're not sure why? Okay. Because if we look here on this very first fraction, what happens here? The x minus 3 cancels. What are we left with? Five x squared plus 15x. We took this 5x times the x plus 3. Then what's going to happen in this middle one? The x plus 3's cancel out. And we're left with what? 4x minus 12. What happens on the right-hand side? X minus 3's cancel and the x plus 3's cancel. So we're just left with 90. So it's a mess to get there, but this is a lot less gross. So we go through a hot mess phase, but then it gets less gross. So let's set this up for us to solve it by factoring. Means I need it to get to equal what? 0, and we're going to combine some like terms. So I've got my 5x squared plus 19x minus what? 102. And yes, we can do this. When we're looking for a big number like this, I just want to talk it through because I know we only have 2 minutes to the end. When we're looking for this to do our splitting apart, we're taking our a times c, which is going to give us negative 5, 10, and 19. When we have a big number like that, focus on our products. We want numbers that multiply to be 5, 10. So we're going to find our factors of 5, 10. I was going to say 51 and 10 are definitely options. We can also have 1 and 5, 10. That's always an option. It's not particularly helpful. I was going to say 34 and 15 is going to be what we wind up with. Which one of those is going to be negative?
15.
the 15 because I need my 19 to wind up positive. So when in doubt, make a list of our factors. And then the last piece I want to point out, because we have 2 minutes at the end, I want to make sure we get a chance to talk about it. When we get down to our solutions, all the way down to x equals, what do we need to do before I can say I have a real solution? Check and make sure what doesn't happen. The denominator is not 0. If you have a solution that gives you a denominator of 0, what's it called? Extraneous. We will keep working through stuff like this tomorrow, but I wanted to make sure we touched on the extraneous part. Okay? So from what I've heard, the emails are still in the process of going out from ACP. So make sure you keep checking your email to make sure you get that login information for IU. Get that login set up. Okay? That is just your IU account creation. So you need to make sure you do that. Our IU registration has to be completed by September the 6th.
Probably.